Okay, welcome to Swell Academy. Today we're talking about finding a vertex of a quadratic or quadratic equation, your x and y, or we would say our vertex. We're going to be working with our standard form, which is ax squared plus bx plus c. So in this case, we have a couple values. We can look here, the equation we're working with for A, B, and C. Now, if they don't provide you with a coefficient for your x squared, which makes our equation quadratic, you're just going to put a 1 there. Now, the first step in solving for your vertex is you want to solve for x. You want to find x. And to do that, we're going to use a negative b over 2a formula or equation. This will help us find our x value of our coordinate. So what we'll do is plug in our values given in our equation. So negative 2 over a 2 times 1. Now keep in mind, it's important that when I plugged in my value, it's negative b. So whatever my b is needs to go inside the parentheses. So in this case, it ends up being a negative. The mistake students will make is that they will put this in as a negative 2, when in reality, it turns into being a positive 2 over 2, reducing to a 1. So in this case, we got a value of 1 for our x coordinate. So let's go ahead and fill that in for our x here. And this is one piece of our vertex. The second thing we want to do is use x to solve for y. And we do that by plugging in our x value. So I'm going to go back to my original equation here and plug in what I had for x, 1 in this case, into my standard equation. And then since I know that this is a function of x, or an output, or a y, I could say that this is equal to y. So what I'll say is 1 minus 2 minus 4. Now don't make the mistake of misinterpreting PEMDAS, when in reality it's multiplication, division before addition and subtraction, what goes first, left to right. So you're not doing 1 minus 6, you're doing 1 minus 2, then minus 4. So we're going to get a negative 1 minus 4 to get a value of negative 5. And this is going to be my value for y here. Now this is going to reveal and allow us to graph and reveal quite a bit about this parabola shape that we're getting when dealing with a well, let's get one going in the other direction, when dealing with a quadratic equation, this parabola shape that we're talking about. Now what we want to do is go to our 1, negative 5, plot that point, and use the key or understanding that if my a is positive, the graph will be facing upward, or if my a is negative, it'll be facing downward. So in this case, it is in fact facing upwards because our a was positive. So it is, or does have a upward shape, okay, which tells us a couple things. Clean up that line there. See if I can create a better parabola. That's better. Our min and max here, and that's going to tell us a couple things. 1, what our minimum is. 2, what our axis of symmetry is, so where our graph reflects, or our line of reflection, in this case, our x value. Our line of symmetry is at x equals 1. We have a minimum because there's a minimum value for y in this case. And we do have a vertex of 1 and negative 5. And when we go to our next step of working with these graphs, we're going to start to take a look at how to identify these zeros, or these values for x, when y is equal to 0. But that we'll talk about when we move forward a bit. Okay, so we have an equation that we're going to look at which has a negative for its a, or the coefficient in front of our x squared, a positive for our b, and we'll just keep the c as a positive 6 here. Again, we're going back to our equation first, negative b over 2a. So let's go ahead and take a look at that. Our b is 8. Our a is a negative 2, so I have a negative 8. I like to put my parentheses to organize my substitutions. 2 times the negative 2. I end up with a negative 8 over negative 4, or 4 for my x. Or 2, I'm sorry. 2 for my x. So that gives me my x coordinate here for my vertex of 2. Now I want to go ahead and second plug in x for y. And I want to do that into the same equation that I began with. And I have a negative 2 x squared plus 8 plus 6. And I'm going to go ahead and plug in that 2. Which gives me a negative 2 times a 4 plus a 16 plus a 6. Which gives me a negative 8 plus 16 plus 6. Which gives me an 8 plus 6, a 14 for my x. So here I have an x and y coordinate, or vertex, for my graph of 2 and 14. Now again, this reveals a couple things when graphing. So I go to 2 for x. I'm just going to assume that's 14 slashes. And I'm going to go to 14 for my y. And with the understanding again, my key tells me a positive a is down, a negative a is up. So I'm going to be drawing or diagram a parabola that is facing down, which gives me a relative max of y is equal to 14. It gives me an axis of symmetry at x equals 2. This is a couple pieces of information, right? My symmetry, my max, and then also what we'll look at in the following videos too, again, is how do we establish these zeros. But you could see there are a couple values here where x crosses, or the parabola crosses our x-axis, which is going to reveal to us what is x when y is 0. And that'll be in some of our following videos here. But, you know, coming up with a vertex, using our negative b over 2a, plugging in for x, plugging x for y are all pieces that you're going to use to develop your parabola graph, find your vertex here, come up with your max, come up with your axis of symmetry here, given any quadratic equation in what we like to call standard form. I hope this helps, and look forward to other videos for how to solve for zeros.